Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to the final Monday. The final Monday for NL Math Man's Math Help Streams. Here we are on day 59. Right? Yes, day 59. That's right. It will be day 61, but there was two holidays in there. Right? Just in the background here today, I went for a little bit of a change of pace. Um, yeah, I thought maybe I would do something special for the last week, but it turns out I'm a bit, I have a bunch of other priorities that need to be get to other than, deciding something fancy for the banter section of my stream, which is, like I said, for the record, this is my this is my break. So today I just went and grabbed a pic of, well, you guys might remember this one. This was sort of our dry run, our COVID-19 dry run, or wet. I mean, it was extreme. It wasn't very dry, really. I mean, although ice, as long as it stays frozen, it's dry, right? But as soon as it like gets down your boots and starts to melt, it's not a dry run anymore, right? But yes, this is from the aptly named Snowmageddon, as we recall. This was our first sort of adventure in distance teaching this year. 2020 has had now, two instances, right? Because like first when Snowmageddon happened and St. John's was shut down for a week and a half because of like record extremely fast snowfall, right? Then we had a distance teaching program at that point as well, right? I don't know if you guys recall. You probably will, right? That we carried on doing work and doing tests and submitting assignments and stuff over distance. Didn't have our math stream then, right? Didn't have our wonderful NL Math Man's Math Help stream at the same math time, the same math channel, right? Maybe we could have used that. Although I don't know how much traction I would have got, starting up a stream and for a week, and it wouldn't have really been ready to go. It's not like my apartment is just perpetually set up for streaming. I guess it would be if I was a streamer, but if I was a streamer, I probably wouldn't also be a teacher. Hmm. Hmm. Anyway, yes. Remember, I don't even have don't even have any stats here prepared for me. I just got this one picture looking out the front of my house, sort of down down the road and then out over the hill, as it is right at St. John's is mostly just a series of hills and valleys. One of the many reasons why the road map of St. John's is so bonkers. But it's a less historically interesting reason than the whole like you know prohibited local governance and all this kind of stuff, right? That we talked about. But anyway, I'm not going to spend a whole lot of time bantering here today because, yeah, don't have anything super interesting prepared. Like, aside from math, obviously, I have math prepared. Math is incredibly interesting, obviously. Like, why else would I be here yammering on if mathematics was not exceptionally interesting? Anyway, so I'm going to go over a few topics here today, as we see over on the side here. Got quadratics. Going to do some word problems and some graphing problems with quadratics. I'm going to do some counting problems recap, and then we're going to go on to simplifying some radical expressions. Okay? So let's start off here. Betty Ann, I know you asked for several different pages, which is great. It's great to have the numbers to choose from, so I don't have to go out and dig through them. I don't mind picking some of my own, of course, but it is nice to have exact ones that the students want, so I know that I'm doing what you're after here. So let's switch on over. Yeah, let's change the background a bit. Right, we just had snow. We just had snow. Let's have something green in the background. Actually, now let's go back to the old green one. There we go. Yeah, I haven't had that background for a while. There we go. That'll be my badge for today. So Betty Ann, I believe you wanted page 335, question 14. Right, so this is going to be math. Was this 2101B unit something? Unit 2, probably? I can't remember. I'll fill that in after. Okay, now this is page 335. And then question 14. So, question 14 is a good one, actually, because it's a good summary of a bunch of different bits from this course sort of wrapped up together, right? Number 14 tells us that an annual fireworks festival held near the seawall in downtown Vancouver choreographs rocket launchers to music. Boy, I assume they mean like fireworks rocket launchers, not like it's not like a Doom guy firing firing off rockets at a cacodemon. Anyway, the height of one rocket in meters over time, t h h of t, yeah, h of t is meters over time. T in seconds is modeled by the function this. All right, so the height of the rocket in terms of time is going to be negative 4.9 times time squared plus 80 time. Okay. Determine the domain and range of the function that defines the height of this rocket to the nearest tenth of a meter. Okay, so remember now, when we talk about quadratics like this, we know that the domain of a quadratic, uh, if it's an actual quadratic, like without any weird sort of restrictions on it, and all these ones are, a quadratic's domain is always all real numbers. There we go. Done. Okay. So the domain is easy. And then define the range. Well, we need two things to define the range. We could just graph it. I mean, we could take this and put it into technology and graph it. But that's a little bit cheating, right? It's not maybe not what the teacher wanted you to do, but it is a great way to check and see if you're doing it right. Because Desmos or a TI-84 or etc. will handle this totally fine. But how's about now we look over? Let's look over at our study guide for a second. Recall back over here in the study guide, right? It has this bit here where it talks about graphing without a table of values, and it says find the axis of symmetry by using the formula this. Now this is extremely useful. A little bit of information to speed up some of the work that you're doing, right? Because we know that the x-chord of vertex, we know that that one is going to be, we write it as x equals negative b over 2a. Now in this case, for this question that we've got here, right, what's our a? Well, the a is always the coefficient on the squared term, so the a is going to be here, it's going to be negative 4.9, right? So in this case, x is going to equal, oh, and the b is going to be 80, of course, right? So it's negative 80 over 2 times negative 4.9. And I put it in bracket, of course, to make it clear that it's a multiply here and not a 2 minus 4.9. So that's going to be x is equal to 80 over 9.8, and I've just canceled both negatives. So 80 over 9.8, so that'll be close to 8. We'll call it 8.16, I'll say. So what does that tell us? The x-coordinate of the vertex. Well, we know that when we're graphing something like this, right, we know that the horizontal axis, right, is going to be the time. We're told that here, right, because we've got h of t and t that we're using, right? So t is taking the place of the x, which is the horizontal coordinate, and that's time. And just something that will serve you well if you go on and do physics courses, you'll know that when you're graphing something, time is always the horizontal one because time doesn't depend on anything else. Other things depend on time, but time doesn't depend on other stuff, right? As long as we're until we're talking about traveling close to the speed of light and all this nonsense, but we're definitely not getting into that, right? But so the height depends on the amount of time. So this is the y and this is the x. And that makes sense as well, right? Because the height obviously is what goes up and down, and you can sort of see the path modeled as a shape like this. Now I know that this one is going to open downwards because that's just the only thing that makes sense, right? It wouldn't make sense for the path of a rocket to be like a U shape, right? That wouldn't make any sense. That's like a yo-yo going down and then up. It's not really like a rocket because a rocket goes up and then down, right? But we also know that this one opens downwards because of this, right? Because the leading coefficient is negative, therefore, there's going to be a maximum, not a minimum. So I'll write that down somewhere over here. Right. So we know that the coefficient is negative, so this parabola has a max, not a min, so it opens downwards, right? So what this tells me is if I go and plug this value of x, or this value of t actually is what it turns out to be in this case, this value of t into here, what I'm going to get is going to be the y value that's going to be the maximum. And then we can use that to figure out our range, right? So let's go and do that. So the y chord, I know that t should have been the 8.16. Um, it will be slightly more accurate if instead of using 8.16 I just use the 80 over 9.8. But whatever, right? It's not going to be. It might be one or two decimal places different than what's in your text, but it's not going to be majorly different. So I'm going to keep that same value and square it, and then times that by negative 4.9. It's going to be negative 326.53 plus 80 times. Actually, I'll do it. I'll do a good show. 80 times 80 divided by 9.8. I'll go ahead and do it out exactly. Plus 353.06. And then the maximum height, as you see, is going to be 653.06. Subtract 326.53. 326.53. What? Oh, look at that. It happened to be, yeah, that was exactly double. Look at that. Anyway, so that is going to be the maximum height that the rocket is going to reach. Okay, so then we know that the range, since that's a maximum, the range is going to be y is less than or equal to 326.53, and also y is all real numbers. Because of course this is supposed to be modeling the movement of an object, and obviously the object doesn't just move in whole numbers, right? It moves in it just moves seamlessly, right? It's continuously, as we call it. It's continuous, right? Okay, let me flip back over to question 14 so I can see it on the page here. What else did they ask us to figure out? Domain and range done as a function of height of the rocket to the nearest tenth of a meter. Okay, well, I did it to a hundredth of a meter there. So I should have had one fewer digits. Oops. One fewer digit. Yeesh. Little subject-verb disagreement. Okay, so yeah, that's the easiest way to go about doing that one. Now you can, like I said, you can plug that into a calculator to check as well. But on a test run, an assignment or something, to get full marks for a question like this, I would want to see figuring out the vertex and then figuring out the y coordinate of the vertex and using that for the max of the range. Okay, so Betty Ann, I believe you also asked for page 363, number 1. Go over here, 363, number 1. There we go. Okay. Zoom in a little bit. For each quadratic function below, identify the following. The direction in which the parabola opens. Well, that's fairly easy. Coordinates of the vertex. Hey, that's what we were just doing. And the equation of the axis of symmetry. Oh, that's a little bit backwards. But hey, why not? Why not? Let's do it in that order. Equation of the axis of symmetry, you kind of get en route to getting the vertex. It's kind of just strictly less than getting the vertex because the x coordinate of the vertex is the equation of the axis of symmetry, basically. So let me give myself a bit more room and use this scene. We don't use this scene so much anymore. I used to rely on this one all the time, but I think the other one works out to be the better one for the way the book is shaped most of the time. There we go. Yeah, that's nice. This is going to be Math 2101B, right? And this is page 363. Question number 1. Yeah, let's go down through. I'll probably go down through most of these, if not all of them. A lot of them anyway. So f of x is equal to x minus 3 squared plus 7. All right, so then f of x is going to be, we're just going to FOIL this guy, right? I'm not going to bother to write it out again. I'll just go ahead because I know it's going to be an x squared, right? And there's going to be a negative 3x and another negative 3x. So that's going to be a minus 6x, and that's going to be a plus 9, right? And it's going to be then plus 7. So f of x equals x squared minus 6x plus 16. Right? And then as we saw from the other one, we're going to have the x-coordinate of the vertex is going to be negative b over 2a, right? Just like it was before. And we have to multiply it out to this point to get which terms are a and b and all that, right? So a is, of course, going to be here. A is going to equal 1, like we see. B is going to equal negative 6. And then c is going to equal 16, though we're not going to have to use c for our purposes here now. So the coordinates of the vertex, well, to get the x-coordinate of the vertex. Oh, yes. Okay. So first up, we should say what direction it opens. Okay, that's true. That's true, because that is part one. I'll do that in a different color here. Oh, that's a pen I haven't used yet. Look at that. So for part one, this one opens upwards. It opens upwards because a is positive, right? We can see here that a is 1. 1 is, of course, a positive number. Therefore, the parabola opens upwards. Right? It's a U shape, not an N. Right? So then x is negative b over 2a is the x-coordinate of our vertex. So we're going to have negative negative 6 or positive 6 over 2. X is going to be 3. Hey, that was hard. That was tough. Right? So now to find the y-coord, of course, we're going to need our... Actually, tell you what. I'll go ahead and write out the solution to the next part as well here right now. Right? The axis of symmetry is just the line x equals 3. Oh, that's part 3, sorry. So I keep thinking that should be part 2 because you kind of get it, like I said, you get that on the way to finding out part 2. But part 3, the axis of symmetry is going to be x equals 3 because that's the x-coordinate of the vertex, which means, right, like if I was to draw out the parabola just real quick here, right, like imagine I was to, right, it would be something like parabola is going to be a little bit like that, although up a fair bit more than that because c is 16. But we know that the x-coordinate of the vertex and the axis of symmetry, right, is actually going to be the same. Just like that. So then now to find the y-coordinate of the vertex, we're going to do f of 3. This is the way we should write it out. F of 3 is equal to 3 squared minus 6 times 3 plus 16. So that's going to be, f of 3 is going to be 9, right? 9 minus 18 plus 16. So 9 minus 2, or f of 3, is going to equal 7. So for part 2 then, we know that the vertex is going to be 3 comma 7. That's all you got to do for these kind of ones, right? So we're just, each of these ones that I do is just going to be these same steps over, pretty much. But I am going to go through and do it a few more. I'll take a sip of my tea. So 1b, m of x, mmx, multimedia extensions. Negative 2 x plus 7 squared minus 3. So you'll see as you go through, Betty Ann, that these questions are really just the same stuff that you've seen a bunch of times before, just with these other pieces added on. But that's kind of, I mean, real talk, I guess. That is the same story with all of these, right? With like pretty much every math unit is always just, oh, it's just the same as the previous stuff with a few more things added on. Yeah, I mean, well, that's just sort of how math is taught, right? So of course we've got two sevens here, we've got a 7 squared here, and we've got x there because there's no leading coefficient in there. So this is now going to be a negative 2x squared minus 28x minus 98 minus 3. So it's negative 2x squared minus 28x minus 101. All right, this is a big one. It's got some bigger numbers in it, but it's not really all that more difficult. So for part 1, we know this one's open downwards because a is negative. Right? That's fairly straightforward. Now let's get the x-coordinate of our vertex, negative b over 2a. So the x-coordinate is going to be negative 28, so that's just a positive 28 over 2 times negative 2. Right? So x is going to be, that's 28 over negative 4, which is going to be a negative 7. Okay, so this tells us then that part 3, the axis of symmetry is going to be x equals negative 7. Right, and it's a vertical line, of course, right? So usually we don't see lines represented as x equals, because it's not, I mean, it is a line, it's just not a function, right? But it's fine for this point, for our purposes here, for we yes, boy, for we to give that, yes, my son, look at that, that's a good line right there. It's a good line for we to give that one. Now, what's the next one here? So I'm just going to go m of 7 is going to equal negative 2 7 squared minus 28 times 7 minus 101. M of 7 is going to be, that's going to be 49. Negative 2 times 49 is negative 98 minus 28 times 7 was 140 plus 56, so 196. Yeah, I should have needed to use the calculator for that. 196, then minus 101. Boy, is this right? Am I doing something wrong here? Did I mess something up? Negative 98 minus 196 minus 101. Negative 395. Boy, that seems a bit, it's a bit of a big one, isn't it? But how about, like I say, right? When in doubt, let's go graph it out and see if, rather than looking it up, rather than looking up in the text, let's go graph it and see if it actually comes out correctly. Right? So it's going to be it was what? Desmos, come on. Oh boy, I'm disappearing. Oh no, he's fading like in Back to the Future. Marty, no. Y equals negative 2 outside of, what was it? I've got my paper covered. X plus 7 squared. Yeah, okay. So I definitely messed something up in there. Yes, I did indeed. Okay. Oh! Ha! Ha! All right. Now I see. Now see? See, it's easy. It's easy to make a mistake like that. It really is. That was, that's the wrong window. It's really easy to make a mistake like that. You might have seen now following along here what the mistake was, but I forgot my negative. I did indeed forget my negative. So that's super easy mistake to do. So this one here should have been a negative 7. Right. Right, see? That should have been a plus 196. And that does it for us. Yes. Yes, it does. See? Boy. But hey, This is why it pays to check your work, right? Pays a check. Negative 98 plus 196 minus 101. Negative 3. There we go. Hey, you did it. So number 2 then, the vertex is going to be negative 7, negative 3. There. That makes a whole bunch more sense. Now let's carry on and do a few more of these. See if I can get them right this time. I've got 50% so far. Right? Maybe I could give myself, some part marks for that last question, but, the final answer was wrong, therefore everything wrong. It's hard laws. Hard laws are on these parts. This is still Math 2101B. Yeah, let's carry on doing these ones. I was wondering if I was going to skip ahead or do D or E, but honestly, E is the easiest one. But no, I should do E as well because E is a little bit of an edge case. Yeah. Let's just carry on to do a lot of them. So it's 7 outside of x minus 2 squared minus 9. So y of x is going to equal 7 outside of x squared minus 4x plus 4 minus 9. So y of x is going to be 7x squared minus 28x plus 28 minus 9. So y of x is equal to 7x squared minus 28x plus 21. Okay. So now we know right away. We know right away that for part 1, our it opens up because A is positive. Negative B over 2A. So that's just going to be positive 28 over 14. So x is going to equal 2. Well, that's fairly easy. Hey. X is a symmetry. X equals 2. And then the y of 2 is going to be 7 times 2 squared minus 28 times 2 plus 21. Y of 2 is equal to 7 times 4, which is, of course, 28, minus 56 plus 21. So it's going to be y of 2 is going to equal, so that's going to be a negative 28 plus a 21 should be a negative 7. Yes. So the vertex is going to be 2, negative 7. Excuse me. D over here. Yeah, I'll just carry on and do this one as well. N of x, 1 over 2, x plus 1. 28 minus 9 is 19. Where did I do that one? Oh, you're right. Yep. Okay. One of these days I'll get a full question right, you know? One of these days I will. One of these days. So that'll be a plus 19 there. So that's going to be a minus, yes, a minus 9. You know, eventually I might even get a whole question right. So, squared there plus 10. Right? This the small stuff is just like calculators are supposed to take care of that, right? Come on. This is not what you really need to know. Arithmetic. Pshaw. Come on. X squared plus 2x plus 1 plus 10. N of x equals a half x squared plus x. It's going to be plus, it's going to be 10.5. Do I want to call it 10.5 or do I want to call that 21 over 2? Now let's carry on with, I'm using a fraction there. So that's, yeah, 21 over 2, we'll call that. That's going to be 1 over 2 plus 20 over 2. So we'll call that 21 over 2. So part 1, parabola opens up. A is positive. So then x is going to be negative b over 2a. X is going to be negative 1 over 1. Oh, well, that's easy. X is going to be negative 1. So part 3 is just going to be x equals negative 1. Yeah, so I'm just going to n of negative 1 is going to equal a half of negative 1 squared plus negative 1 plus 21 over 2. So n of negative 1 is going to equal negative 1 squared is positive 1. So this is a half minus 1 over 2 minus, I'll write it as 2 over 2 plus 21 over 2. Right? So this is that's just going to be 20 over 2 or 10. So then for part 2, we have, the vertex is going to be negative 1, 10. Provided I got all my arithmetic right. You know, the method is still good, right? That's what I tell myself. The method's still good. Let's just cram E down here on the bottom here. Cram E in there because E will be a little bit shorter. R of x is equal to negative 2x squared plus 5. Because right from the start here now, I don't have to do out this stage for this one because this guy is already sort of expanded, right? So right away here we know that our parabola is going to, I'll just do it all in black. Parabola opens down, we know that, right? To get the x coordinate, we're going to do, well, negative b. This is the reason why I wanted to do this one out, right? What do we have for b here? Well, there's no b term listed, so what number do we use? We use 0, right? Because if there's no b term, well, then we're just going to use a 0. So it's negative b over 2a. So x is going to be 0 over 2 times negative 4, or x is going to be 0, right? So we see that for the middle term, if the middle term isn't there, no matter what the other terms are, right, it doesn't actually matter because our axis of symmetry is always going to be 0. Right? That's how this one has a bit of another wrinkle here. Right? So then for part 2, well, if we do r of 0 is going to equal negative 2 times 0 squared plus 5, which is, of course, going to just be the 5. So part 2 then, the vertex is going to be 0, positive 5, like so. Okay. And now I believe, yes, Betty Ann, you asked for some off of page 366 as well. So let's look over at those here, page 366. Scroll down the same PDF. 366. Okay, let's start at question 12. The vertex of a parabola is 4, negative 12. Write a function to define all parabolas with this vertex. Oh, okay. Interesting. So the vertex of a parabola is at 4, negative 12. Hmm. So how are we going to write one to define all the functions, all the parabolas with that vertex? Well, what do we know about it based on this, right? Well, we know that vertex is going to be 4, negative 12, right? So we know that x equals negative b over 2a, right? Like that. So we know that 4 is going to equal negative b over 2a, like so. Or what we can rewrite this now, right? To say that, say 8a equals negative b. We could call that, or we could say that a is equal to negative b over 8, right? We do know that both those things are true, right? And then we know that y equals ax squared plus bx plus c, right? We know that negative 12 is equal to, well, we could call this a times 4 squared plus b times 4 plus c. Um, yeah, I mean, there's honestly not a whole lot further we can go with this one now, is there? I mean, we can say negative 12 equals 16a plus 4b plus c, and we could even rewrite it to have this in there instead, say negative 12 equals um, negative 16b over 8 plus 4b plus c. So what we end up with then is negative 12 equals negative 2b plus 4b plus c, or negative 12 is equal to 2b plus c. Okay? But now we still only have one equation. We have one equation and two variables. So we can't really define what this is going to be here, right? But we know that as long as this is true, right, then we can have a parabola with that vertex. Um, now, did your no, I didn't look down through the book there to see what way they suggested solving these ones. So I'm really just going off the cuff here, right? But this is sort of the way that we would reduce it down and simplify it using systems of equations, which is stuff that we've seen before. Quadratic functions are written in vertex form as the following characteristics. Yeah. Okay. So we could, yeah, the vertex of the right where this is the coordinates of the vertex. Okay, that's what they want. Yeah. Okay. So what I've done here is still correct, right? But it's perhaps over engineering this from a bit from what we need to do with that one, right? So the vertex of the parabola is coordinates h and k. So we would call this y equals a x minus 4, right? Minus 12. But the thing is, but we still can't do really anything with this formula, just like this one that I found over here, right? Which does still work. we can't do anything with this one, and we can't do anything with this one beyond this point. And why is that? Well, it's because we've got this value over here, right? And basically what that tells us is because when we have a parabola, like so, there's an infinite number of parabolas that have a given vertex, right? Like say this was the vertex here. It could be a parabola like that. It could be a parabola like that. It could be a parabola like that. We don't actually know, right? All we know is that it has this same vertex. So there's still an infinite number of parabolas that can fill this form basically, right? And that's why this term A is in here. So parabola with this vertex passes through point 13, 15 and determine the function of the parabola. Okay, well it's going to be a lot easier. It's going to be a lot easier, like they're saying, using this down here. Okay, because this is the form that they show in there. So all we had to do now is once we know one other point on here, right? Like you see how I've drawn all these ones. Parabolas are always going to be um, mirrored, right? Because we know the axis of symmetry is going to come down through here like so, right? So as soon as we know one point, like if we knew this point was on it, was on the parabola, then all of a sudden only this one parabola here is possible, not this one or that one or anything like that. So all we really have to do once we know a point that's on there is to go and take this one and then put the other part into it, right? So in place of x and y, I can put in this 15, 13. So 15 can go here, equals a times 13 minus 4 squared minus 12. 15 is equal to a times 9 squared minus 12. Or I should have added that over to the side. 27 is equal to 81a. 27 over 81 is equal to a. Excuse me. 27 over 81 is going to be what, 1 over 3? Yes, that's right. 1 over 3 equals a. Okay? So determine the function for the parabola. State the domain and range of the function you determined in part B. Okay, sure. Sure. Now we'll see perhaps, anyway, let me show you here now. I think you might see how it links back to what I was doing. So we're going to have y is equal to 1 over 3 outside of x minus 4 squared minus 12. So y is going to be, once we multiply this out, it's going to be 1 over 3 x squared minus 8x plus 16 minus 12. Right, so that's going to be y is equal to then 1 over 3 x squared minus 8 over 3 x over 3 minus 12. Okay, I'll just do it like this. 16 over 3 minus 36 over 3. So y is going to be 1 over 3 x squared minus 8 over 3x minus 20 over 3. Right, so that's sort of another way that we could write it out sort of back in this form. Granted, it would be easier if I called this a 3y over here. So perhaps I could have just called it that from the start and then brought the 3 over afterwards. That would have been a little bit, but then I still would have had to change this number over here. So no, that's probably the easiest way to do it. Okay, so state the domain and range. Well, again, right, our domain is always going to be this is all real numbers. I can't even recall. Does your book even ask you to do question 12? But either way, um, so the range now, right? We're going to find the y coordinate of the vertex, like we were talking about, right? Well, we know the. Oh, okay, okay. I'm really just sort of barreling on through it here and trying to get this stuff put down so you see the relations between it. Uh, okay. I need to pause and take a step back. Well, we see our x coordinate. Our a term is positive, right? The a term is positive, which means it opens upwards. We're already told the vertex, right? So we just know that y is going to be greater than or equal to negative 12. So once we go through here and we figure all this stuff out, we would get that y is greater than or equal to negative 12. Part of the reason I was going through here to do all this stuff out is I did kind of want to show that it was going to work out, right? So we're going to have, if we look back over on this one here, we would have negative 16 over 3, right? Minus 20 over 3, which does indeed give us our negative 12. So what I was doing what I was doing over here did work, and I was kind of anyway. I wanted to show how it would link back up, but you know what? The easiest thing to do was just to use what the book was telling you from the start. Tell you what, let's do a different one, and let me check your study guide. So let me check your study guide and see which of these questions on this page do you have to do. So this is question 366. 366. 1, 3, 4, 5. Okay. So let's do. Oh, that was question 12. Yeah. 12 B, C, D. Huh, weird. So they didn't want us to do 12A. What? Why did they not want us to do 12A? Write a function to define all parabolas with this vertex. Oh, so this part I was doing here they actually didn't want us to do. Well, oops. 12 BCD number 14. Okay, so let's do number 14. Number 14 is the one they're asking us for. Because that honestly might have been a bit more confusing than what than what you were doing. Okay. So a parabolic arc has x-intercepts, x equals -6 and x equals -1. Parabola has a maximum height of 15 meters. Determine the quadratic function that models the parabola. Excuse me. So we know that we do know 2 points on the parabola, and we do know the vertex as well. I'm wondering again, right? I'm wondering what way I should show this one to you, because we do know, right, that say for any parabola like this, right? Now this might be seen as being a little bit cheating, but I think this is actually the way they want you to do it, right? We know that x equals -6 is going to be on there, which is down here, right? So that's one of the roots of the equation, and then x equals -1. That's another one of the roots of the equation. So if those are both the roots, and we know that it has a max at 15 up here, right? May as well be learning a new language. Yeah, it sort of is like that. But we do know that it's always going to be halfway between, right? If we have two roots, the um, like if we have 0 roots, we can't do this. But if we have 2 roots, we know that the vertex is always going to be halfway between those roots. So -6 plus -1. Right, well, what's halfway between -6 and -1? Well, it's going to be it's going to be sorry, it should be minus a -1 because it's going to be -5. So it's going to be -2.5, right? And -3.5. Sorry, yes, it is going to be -3.5. So now, because this is halfway in between those points, right? We know that -6 and -1 are the two roots of the parabola. And we know that it gets up to a height of 15. So we know that it's going to be -3.5, and 15 is going to be the vertex of that, right? So determine the quadratic function that models the parabola. Well, that's most easily done using this formula that we have up here, right? Because this formula that we have, all right, let me just, I got to take a step back. I've been doing so many different things today that it's just a cluster of stuff that I'm doing. Okay, so it's y equals ax minus h squared plus k, like it says here, right? And what this allows us to do is allows us to fill in, we can just directly fill in the vertex as h and k. And then as long as we have one other point, any other point at all, then we can go ahead and solve and find a, right? So we now have the vertex because we know the vertex has to be halfway between the two roots, right? And we're given the y-coordinate of the vertex was 15, so we know that the x is -3.5. So we know that h, the vertex in this form is going to be h comma k. So it's going to be ax plus 3.5 squared plus 15. It's going to be a plus because it's normally a minus from the start. And instead of calling it 3.5, let's call it 7 over 2. That'll make the squaring a little bit easier. Let's call it 7 over 2. Right? But now I can go ahead and fill in 2 of these points here, right? Because we know we have 2 other points now. We have -6, 0 is 1, and we have -1, 0 is another one. I'm going to use -1, 0 just because 1's a smaller number than 6, but it's really not that much different, right? So y is going to be 0, a is going to be here, x is going to be a -1 plus 7 over 2 squared plus 15. So 0 is going to equal a outside of, it's going to be 5 over 2 squared plus 15. Or I can move the 15 over. -15 equals 25 over 4a, like so, right? And I'm going to bring this up here. -15 times 4 over 25 is equal to a. -60 over 25 is equal to a. So that's going to be negative, what is it, 12 over 5 is equal to a. Okay? Determine the quadratic function that models the parabola. Well, it's going to be, we can, now that we have a, we have our quadratic function. So the quadratic function can be, we don't necessarily have to write it in the expanded form like I did earlier. I just sort of, I guess, automatically start barreling toward that sort of form, but there's no need to. There's really no need to. So that now is our quadratic. Because what we did, right, was we knew that the vertex is going to be halfway between the two roots, like so, right? And then, so it's -6 and -1. So halfway between -6 and -1 is going to be -3.5. So we add them together, get -7 divided by 2. So -3.5, 15 is our vertex. So we plug that in here for h and k. And then we pick either of these roots, and those can be the points. This point here and this point here. Now, to do 12b, state the domain and range of the function. Well, that's not hard, right? Because we know the domain is always going to be x is all real numbers, and the range is going to be y is less than or equal to 15. Y is all real numbers. Okay? Yeah, I hope that helped a bit. Apologies for that last question that I sort of went off the rails there a bit, but hopefully you understand that this form here, this form that we're using there, um, is nothing super complicated, right? It's just that this is a different way of representing out the formula of a quadratic, where we can draw the vertex right in there. Okay, let me know if there's any other questions that you would like me to do on this topic. But for now, then, stream starts soon. Nope, the stream's going. I'm gonna go back over and take a quick, take another quick look at what January. Right, that was January. That feels like, boy, oh boy, that feels like 100 years ago right now. To be honest, this is, I mean, it's only what is it? It's only June, and it's already been 2020 for like 6 years at this point. Um, so yeah, I'm going to go on with a few things on counting problems and probability. I'm maybe not going to do everything that I had lined out to get to because I have quite a lot lined out. Like I said, Betty Ann, if you've got any other questions about those, do let me know. I can do some more on stream here now if you drop some numbers in chat for me to get to. I understand if maybe some of that was a bit more confusing than it was at the start. But let's see here. Okay. This is going to be math. What is this course? 3101A, Unit 3. All right, I'm just going to quickly go down through some of these ones. Going to try to go down through these real quick. Right? Josephine plays ringette. She scored 3 times with 15 shots on goal. Says the odds of her scoring are 1 to 5. Is she right? Explain. Well, no, she's not. She's not right. Because remember, probability is equal to favorable over total, right? So here, her favorable is going to be 3 out of 15, which is equal to 1 out of 5. But that's favorable over total. Remember that odds, right? If it's not specified, we mean odds in favor. So the odds in favor are always going to be favorable to unfavorable, right? So if it's a 1 in 5 probability, or 3 in 15, 3 times was favorable, but 15 it wasn't unfavorable. It was unfavorable the rest of the time, so it was 12. So the odds is actually going to be 3, yeah, 3 to 12, or 1 to 4. 1 to 4 is what the odds are actually going to be there for that one. 22. Credit card company randomly generates temporary 4-digit passcodes for cardholders. Repetition is allowed. Serena is expecting her credit card to arrive in the mail. Determine the probability her passcode will consist of 4 different odd digits. Okay. So remember, probability is what we're looking for. So probability is favorable over total again. Right? So what's the total here going to be? Well, we know the total. We were told that it's 4-digit passcodes, and repetition is allowed, so it can be any digit. So the total is just going to be 10 times 10 times 10 times 10. It can be 10,000. That's it, right? 1 with 4 zeros, easy. Because it's 0 through 9, so it's 10 different digits. And then the favorable, well, the favorable is going to be, we're looking for it to be 4 different odd digits? Well, we know that there's 5 odd digits in total, right? 1, 3, 5, 7, and 9. And we want them to be different each time. So it's going to be 5 times 4 times 3 times 2, which is the same as 5 factorial, which is the same as 120. So the probability is going to be 120 over 10,000, which is going to equal, I shouldn't actually use a calculator for this, right? 0.012. And remember, now I know this is a subject from a previous course, but you do still have to remember how to do this to convert from decimals to percent. That is, or 1.2%, right? Because percent literally means out of 100, so we multiply by 100 to get from decimals to percents. Right? Let's do 23 here. From a committee of 12 people, 3 people are randomly chosen to be president, vice president, and secretary. Determine to the nearest tenth of a percent probability that Jerry and Bill are going to be the president and the vice president. Okay? So, well, what's our total going to be? Well, here the order does matter. The order does matter because if you pick Jimmy, Timmy, and Kimmy, right, to be president, vice president, secretary, well, that's different than if you pick Kimmy, Timmy, and Jimmy to be president, vice president, secretary in that order, right? So the order does matter, and because the order matters, we have to use P, right? So our total is going to be 12P3, like this. And what's our favorable going to be? Well, we need to get Jerry and Bill to be president and vice president. Now, it doesn't say that Jerry has to be president and Bill has to be vice president. It says that those two have to be those two positions. So we need those two arranged, right? So it can be Jerry and Bill, or it can be Bill and Jerry. So we know that that's 2 orders, but the way that we will represent it in our math terms is 2P2, because there's 2 people, and we're picking both of them, but we're putting them in all the possible orders that they can go in. And that's what 2P2 means, right? And then, so the next one is going to be how many people are left over? There's 10 people, and we're going to be picking one of those. Now, of course, 10P1 and 10C1 are the same. But another thing, like I mentioned, don't mix and match. Don't mix and match C's and P's in the same question. Either the order matters for the whole situation, or the order doesn't matter for the whole situation. All right, so then our probability is going to be 12P3 over, sorry, no, what am I doing? It's going to be 2P2 times 10P1 over 12P3, which is going to equal, right? So I'm just going to do them all out sort of at the same time here. I'm going to keep them down at the bottom here, and then we're going to go ahead and do some other questions over here on the side. So this is going to be 2 times 10 over 12 times 11 times 10. So that's going to cancel with that. And this is going to cancel and make this into a 6. So that's going to be equal to 1 over 66, which is equal to 0.0152 or 1.52%. So not a big chance. Not a very big chance that out of those 12 people, Jerry and Bill will be president and vice president. Right? But that's the way that we're going to go about finding that guy. Right? And then just to recap, it was 2P2. This one's a little bit tricky to get, maybe. But what that means is there's 2 positions, right? President and vice president. And there's 2 people to fill those. So we do 2P2 to say, well, how many different ways can we fill 2 spots with 2 people? Turns out the answer is 2, of course, because it's n factorial over n minus r factorial. So here it's 2 factorial over 0 factorial, and 0 factorial is 1. Right? Let's do question 29 here. So a student council consists of 12 girls and 8 boys. To form a subcommittee, 4 students are randomly selected. The odds in favor of 3 girls and 1 boy being on the committee. Now we're looking for odds, but let's hold off on the whole odds thing for the start. Now let's convert it to odds at the end, right? So what's the total? Well, to form a subcommittee, 4 students are randomly selected, but they're all on the subcommittee, right? So they're all on the subcommittee together. So is that going to be, does the order matter? Right? Again, right? Is Jimmy, Timmy, Kimmy, and Lemmy, Skimmy? I don't know. I need another one that rhymes. My Theodore I'm not channeling Theodore Giesel well enough. Wait, I just don't have the energy. I don't have the don't the just raw intellectual power to tap today to be able to channel the brilliance of Dr. Seuss straight through my mouth and into your ears. It's getting weird all of a sudden. Boy, see, this is how it goes. This is what happens, Larry. So, but remember, the order doesn't matter, is what I'm saying. Dan, Pan, Fan, and Chan, right? Or Chan, Pan, Fan, and Dan. It's going to be the same group. Okay, so some of the odds in favor of 3 girls and 1 boy. Well, our total is of course going to be, so all that beating around the bush I was saying is that we're using C. We're using C because the order doesn't matter. So our total is going to be 12C4, right? Which is going to be 12 factorial over 4 factorial, 8 factorial. So it's going to be 12 times 11 times 10 times 9 divided by 4 times 3 times 2. 4 times 3 is the same as 12. A 2 can cancel there and make that a 5. So that's going to be 55 times 9, which is going to be 450 plus 45, which should be 495. Hey, sometimes I can get arithmetic correct. Occasionally I can still pull out a little bit of correct arithmetic. But it's no good, right? It's no good to just be able to do it sometimes. You got to be correct all the time. That's the problem, right? Determine the odds in favor of 3 girls and 1 boy. Well, what's our favorable? Right, so our favorable is 3 girls and 1 boy. So there's, oh my God. Okay, well, occasionally, is this even going to be useful? No, it's not. Don't mind me. Don't mind me. It's going to be 20 C4. 20 factorial over 4 factorial 16 factorial, which is going to be 20 times 19 times 18 times 17 over 4 times 3 times 2. I have officially, boy oh boy, I'm officially phoning it in today. All right, 20 times 19 times 18 times 17 is that much divided by 4 times 3 times 2. Not even going to trust myself to multiply that out in my head. 4845. All right, we got there. We got there eventually. We got there after a few mistakes, right? Hey, these things happen. So then our favorable, right? And the reason that was wrong, of course, 12C4, because I just looked at the 12 girls and went ahead and used that number. Really, really slipping. You catching me slipping today. Catching me slipping, Twitch chat. Although there's nobody right here to catch me slipping. But after I bold-facedly linked this video to students as if this was something from which to learn mathematics, then they will catch me slipping indeed. Boy. Hey, in 59 streams, right? 59, that's like 59 times like an hour and a half. And early on, it was like 2 hours, 2.5, 3 hours, right? So, I mean, you're looking at a solid like I mean, you're looking at close on 150 hours of mathematics streamed so far by NL Mathman, right? If I get stuff wrong, only like if I only spend like 30 of those hours getting things wrong, it's not bad, right? 15 maybe. Hey, if I could get math wrong for a solid 15 hours and still have 90%, right? Think about that. That like I haven't gotten stuff wrong for 15 solid hours, not a chance, right? So I'm still, I'm above 90 even. That's not even a 4.0 GPA, right? That's not even an A. That's like a good A, right? Come on. That's what I'm saying. That's what I'm saying. You just gotta have realistic expectations. So favorable is going to be three girls and one boy. So this is going to be 12C3 for real this time. And then that's going to be 8C1, right? So it's going to be 12 factorial over 3 factorial 9 factorial times 8 factorial over 1 and 7. So that's going to be 12 times 11 times 10 over 3 times 2 times just 8. Right? So I could cancel that into here and call this 2. So it's 22 times 10 is going to be obviously 220. 220 times 8 is going to be 1600 plus 160, so it's 1760. 1760. Hey, look at that. All right. Once upon a time, the teacher could do math. So then what's our unfavorable then? Unfavorable is going to be total minus favorable, right? So the unfavorable is going to be 4845 minus 1760. So the unfavorable is going to be 4845 minus 1760, 3085. So the odds, right? We were asked for odds. Okay, so this is still part A. The odds is going to be 1760 to 3085. And now we could go ahead and put that in simplest form, right? So let's divide both those by 5 and see what we get. So that's going to be a 617. I know they can both divide by 5, of course, because one ends in a 0 and one ends in a 5. 1760 divided by 5 would just be 176 times 2, which would be 352. Hey, look at that. Got him. GOTTEM. Okay, in terms of probability as a percent of there being at least 3 boys on the committee. Yeah, I'm gonna finish up this question, and then I think, yeah, yes, that is the last one that I want to do on this topic, so I'm gonna move on. There being at least 3 boys. I don't have enough space to do that on here, unfortunately, so we're gonna have to break out a new page over here. This is gonna be Math 3101A Unit 3 still. This is going to be question, what is this, 29B. Okay, so at least 3. So there's 4 students being shown, so at least 3 or 4 boys chosen, right? It's really important. Now it's a crappy way to lose marks in a math course, I know, but you are going to lose marks if you see at least and you think that's 3 or less, right? I understand sometimes, like interpreting the words, sometimes it would make sense to think of it as 3 or less, but it's not. At least 3 means it's going to be 3 is the minimum, so it's going to be 3 or 4, right? Because 4 is the maximum here. So we know that our total from before was still 20C4, which equals 4845. We had that from our previous page, right? So then the favorable, well, that's going to be 2 situations, right? So at least 3 boys. So to get 3 boys is going to be 8C3. And when we do 8C3, we also are going to need to do 12C1, right? I know what I told you before that with 1, you could do C or P, but we will always be consistent. If we're using C's in a question, we're going to carry on using just C's in that question. Then there's an or. An or in math means you add, right? Or in probability like this, it means add. And then we have 4 boys, so it's going to be 8C4, and I'll put in the times 12C0, although anything C0 is 1, but I'm putting it in there just to be very thorough. Right, so then the favorable is going to equal 8 factorial over 3 factorial 5 factorial times, again, right, I know, if you have a calculator that can do this, it seems like a total waste of time to be writing all this out like so, but I'm still going to do it because technically in this course, you're not meant to be using like a calculator like that, but like who really cares, right? It's totally practical to just sort of show that you know how to do these sometimes. But like I say, when you do have these questions, the reason why there's so much space left over there for a question like this is because we are expecting the C's, the NCR and NPR to be done out like this. Although you're encouraged, more than welcome, encouraged to use your calculator to check your answers for these things. Right, so that's just going to be 12 factorial over 12 factorial over 1. So now this 3 and this 2 are going to cancel with that 6. This 3 and this 2 with that 6. That 4 can cancel there and make that a 2. So we're going to have 8 times 7, which is 56. 56 times 12 is going to be 560 plus 112. So it's going to be 672. Yes, that is right. 672 plus, this is now going to be 2 times 7 is 14. 14 times 5 is 70. 70 times 1 is 70. So it's going to be 742. Okay, so then our probability, of course, our probability is always favorable over total. So the prob here, the prob bob, is going to be 742 over 4845. So the probability is going to be 742 over 4845. 0.15. Does it say rounded? It doesn't. But we're going to do it as a percent, so that then equals 15.3%. So the probability that there will be at least 4 boys is only 15%. Makes sense. There's fewer boys than girls in this setup, so the chance that at least half of the crowd, chance that the majority, excuse me, chance that the majority of the group will be boys is relatively low. Okay, so Calais, that was for your previous one. Now you did also ask about simplifying radical expressions. So I will. This is going to be a quick look at it. I know you've gone on a little bit here with these ones. I do caution you to sort of knock out the previous one a bit first, partly because, like I'm saying, right, if you're not transferring to Kenmount, which from our conversation earlier, I gather you're not intending to, that means that we will be cluing up here at the end of this week. So I would strongly encourage you to just get 3101A sort of out of the way first, which means the review sheet for the current unit and the test in the current unit, and then the overall test in the course. So get those out of the way before you really concern yourself very much with B. When I sent you the guide for B, I wasn't. Oh, hold on a second, please. Okay. When I sent you the guide for B, I wasn't 100% sure if you were going to be transferring or not, right? So I didn't, I didn't really know if I should be going through that one with you. But I understand that, yeah, if you're not going to Kenmount for the summer, after this week ends, you won't be back at math until September. So it might be a little premature to be looking at the radical expressions for Unit B, but you did ask about that, and I told you I would cover some. So I am going to go down through this topic a little bit here now. Okay, so let me bounce back over to my document display. This this topic is really not too bad, to be honest. So I'm just going to walk you down through some of the examples that they have here in the textbook, just as a really brief introduction, and then afterwards you can tell me, you can sort of let me know if this made any sense at all, right? Or if this is the kind of stuff that you're looking for. But like I said, I'm not going to go into too much detail here because I think you're better served by focusing on the current course and getting that one out of the way before you move on, right? But a is going to be 4x squared over 12x. Now, when we do our NPVs, it's important to know that the non-permissible values, or NPVs, for these questions are always from the original. The original, not after we simplify it, right? Because the thing is, and that's really important for a question like this, because after I simplify this question, there actually aren't any NPVs at all. None whatsoever. But for this exact one, with the x on the bottom still, there are. And it seems a little bit counterintuitive, right? Because it's kind of drilled into your head over and over in math that you should always simplify something as much as possible first, and then once something is simplified, then you go ahead and do other math with it. But in this case, we don't. In this case, we actually, NPVs are a strange one in that we take those based on the very first version and not on a later version that already has things canceled. So what causes NPVs? Right? Well, just like we saw in a course recently, we can't take the even root of a negative, can't do that, and divide by 0. Basically it. That's pretty much it. You can't take the even root of a negative, and you can't divide by 0. Right? So here now, is there a square root in the question? Well, there's no square roots, so that part of the NPVs is not, we don't even need to concern ourselves with. But how about dividing by 0? Well, if x equals 0 here, we would be dividing by 0. So x cannot equal 0. That's all we got to write out. That's all we got to write out for our non-permissible values. So then we just simplify the question. Well, that's super easy, right? 4 over 12 simplifies down to being 1 over 3. And then x squared over x just becomes x, like that. So it's just a third x. Now, once we've simplified it, now it could be 0, right? But for this one, it can't. Strange enough, right? But that is how it works. That is how it works for these questions. Okay, let's look at part B here. B is 5x squared plus 25x over 10x plus 50. Right? So again, we're going to do our NPVs. I'm going to keep doing them in red. NPVs. Well, we know that 10x plus 50 cannot equal 0, which means 10x cannot equal negative 50, or x cannot equal negative 5. Right? Because just like we've seen before, right, an inequality, something like this, saying it doesn't equal, that we just treat that exactly the same as if it was an equal sign, as far as we're concerned for doing our algebra like that. Right? That's all we need to do there. To simplify these guys down, though, what we can do now is we can start factoring out terms, because here, this is a good example, because this one has a binomial on top and a binomial on bottom. And we know that in order to cancel something out of a binomial, we need to be able to divide both terms in the binomial by that number evenly. And a term in a binomial is anything, or in a trinomial or a polynomial, I should say. A term in a polynomial is anything that's separated by a plus or a minus. So here, this is a term 10x, this is a term 50, this is a term 5x squared, and this is a term 25x. So anything that can cancel out of the question entirely has to be in all four terms. But let's just factor them out of the top and the bottom first. What can we factor out of 5x squared and 25x? Well, we know that we can divide both those by 5 evenly, and there's an x in both, so we can divide both by x. So we can represent it as 5x outside of x plus 5. Right? And this is just factorizing that you've seen, I'm sure you've seen this plenty of times before. And on the bottom here, we can take a 10 out of both, can't we? Right? But then we can't take an x. We can't take an x out of both. But once we take a 10 out of both, we end up with this being x plus 5. Ah, look at that. What in the world is going on here? Well, we know very easily that we can cancel this 5 and this 10 and call this 1 and this 2, right? That's pretty straightforward. We know that. But we can also cancel entire brackets of things, like that and that. So we just end up now with x over 2. That's it. Now remember, like I said up here, if you tried to get your NPVs from the end version, then right here you wouldn't actually appear to have any NPVs. But you do. X does not equal minus 5 because this is the form we start with. And we don't use our simplified version to find our NPVs. We use our original version. And it's sort of an interesting point, right? Something that you don't see in earlier math courses very much. But because oftentimes we're told, oh, a simplified version is just the exact same thing. It's just written more neatly. Well, yes, but actually no. Right? Because our non-permissible values are different. Y squared minus 9 over 2y plus 6. Right? So again, let's do our NPVs. Well, there's no square roots here, so we don't even need to bother with the first one, even root of a negative. There's no roots here whatsoever. But our NPVs then, we know that 2y plus 6 can't equal 0, which means 2y can't equal negative 6, which means y can't equal negative 3. Okay? But now we can continue on with this guy over here. Now remember this one on top. This one on top here is one of the special cases that you've seen before. This one is the difference of two squares. Remember, this is one of your factoring cases that you can do more quickly because it's one of the sort of the shortcuts. Right? The difference of two squares. I'll write that over here. The difference of two squares is x squared minus y squared equals x plus y times x minus y. So if you have a number first that's something squared and the second one is subtracting something that's also squared, you can simplify it down very quickly into x plus y times x minus y. Right? And I know you can kind of say, oh, well, aren't we breaking something down? Isn't there an even root now? Because we're breaking this down. We're taking the root of negative 9. Well, we're not taking the root of negative 9. We're taking the root of 9 and putting a negative and a positive root of 9 over here. Right? And also this first one, well, this is already squared. Right? So if y was negative 1 squared is going to be 1. Right? And we're just gonna take the principal root of it anyway. So it's a long-winded way of saying no. There's still no square roots here. So this is going to be y plus 3 times y minus 3. And that's going to be over. We can take factor of 2 out of both these, right? We can call that 2 outside of y plus 3. Then you can quite clearly see that this y plus 3 and this y plus 3 cancel. And then we're left with y minus 3 over 2. And again, right, at the risk of just beating this to death, by the end, we have a function that doesn't have any NPVs, but we still have NPVs in this function. Yeah, let's pound down through D and E. here, and then that should probably be enough examples for this for right now. 4 minus 2a over a squared minus 4, right? So our NPVs, a squared minus 4 does not equal 0. So a squared does not equal 4, or a does not equal 2. Okay, so that's our NPVs there. You know that a can't be 2. To carry on with this guy then, again we have a difference of 2 squares. Right? We have a difference of 2 squares here on bottom. So this is going to be 4 minus 2a. Actually, scratch that. I'll go ahead and simplify it. That'll be 2 outside of 2 minus a over a minus 2, a plus 2. And now what have we got? Now what have we got indeed? This one does have another little wrinkle, actually, that you will see come up again as well. This looks a lot like this, but the signs are swapped, right? So here this is a positive 2 and a negative a. Here this is a negative 2 and a positive a. Now it has to be this one that it compares with, right? Because over here the signs are the same on the a and the 2. Here the signs are different, and here the signs are different, but they've been reversed. So how can we get them to flip back over so we can start canceling and make our equation a bit simpler? Well, you can factor out a negative 1. If you factor out a negative 1, because if I took this and multiplied it by negative 1, both the signs would switch, right? But on the same token, I can kind of factor out a negative 1, because I can divide this evenly by negative 1. Well, 2 divided by negative 1 is negative 2. And I can divide this one evenly by negative 1. Negative a divided by negative 1 is positive a. So what I can call this then is 2 times negative 1 times a minus 2. That's going to be over a minus 2, a plus 2. Now, the a minus 2 and the a minus 2 are going to cancel. So now, I'm going to be left with negative 2 over a plus 2. Oh, right, right, right. Okay, good, good. This is another teachable moment here that I had missed. Yes, we need here now to put in negative 2 as well as an NPV. That's right. That's right. We absolutely need to. Because if a squared does not equal 4, well, what numbers squared make 4? This actually goes back to what Betty Ann was doing just now, right? Because of parabolas, right? We can see that with the quadratic, right? There's always going to be 2 numbers, right? That when squared make 4, and those are going to be the positive and negative. Sometimes when we use the roots, like the symbolic root, the root sign, we are only concerned with the principal root or the positive one. But in this case, we are concerned with both roots, the positive and the negative. Okay, so let's go on with E over here real quick. So E looks a little bit more intimidating than the others, but really it's not bad at all. It's just a few extra pieces. If anything, it's a little bit easier than some of these. 3m cubed minus 4m squared. Now, I know I talked a whole bunch about how we use the original form for NPVs. I lied a little bit. We can sort of regroup things and we can factor stuff out. We just can't cancel anything. It's the canceling that actually changes what the NPVs are and aren't. But regrouping things is totally fine, right? So here, instead, how about I call this one 2m outside of 3m minus 4, and I call the bottom m squared outside of 3m minus 4. Right? So now once I arrange it like this, Now we're finding our NPVs is a lot easier, right? Because our NPVs from this one over here is going to be this whole bottom, m squared times 3m minus 4 cannot equal 0. And this now, you might recognize the sort of math that we're doing here, right? Because this is just like solving a quadratic, right? In the sense that these are two things multiplied together. So if this is going to be 0, either of these things can be 0. So over here, we know that m squared can't equal 0, or m can't equal 0, right? And then for this one here, we have 3m minus 4 cannot equal 0, which means 3m cannot equal positive 4, which means m cannot equal 4 over 3. Right? So there's our NPVs. And the NPVs have to come down from this step before we cancel. Right? So I'm going to say, yeah, I'll put it over here. Take NPVs before canceling. You can reorganize, you can rearrange, but you can't cancel. Okay, but now we're going to cancel. I'm going to cancel this 3m minus 4 with this 3m minus 4. I'm going to cancel this m squared with this m. And that's just going to equal 2 over m. And we see even in our most simplified form, we do still have some NPVs here. M still can't be 0, but the 4 over 3 NPV is now gone because it cancels with what's up top. But like I said, take your NPVs before canceling, which is especially important for this question here. Okay, Calais, I hope that is a decent look at the beginning of that course there for you. But like I said, don't spend in a large amount of time looking at that one quite yet. Because like I said, with us ending off here now at the end of this week, we do need to be prioritizing a bit, right? This is sort of I don't want to say a triage situation. That's what I was thinking, but then again, you actually work in healthcare, I believe, right? So that's it's a bit grim. I'm just thinking more of like your some of my past experience being in a kitchen and being in the weeds, as we call it, right, and having to prioritize what comes in and what goes out. Adventures in part-time work during college, during university. Anyway, yes, my point is, let's prioritize getting the current course done and over with and out of the way, so you've got that credit under your belt, right? And that way, if you switch to Kenmount, or if you come back in the fall, or even if you take some time off and come back later, a fully completed course will stay with you. You will have credit for a fully completed course. No one can take that away from you, no matter if you go somewhere else, or if you, like I said, or if you decide you don't want to come back in September, maybe you want to come back in October, that fully completed course will stay with you. But if you take some time away and maybe come back and there's different staff or something like that, they might not be able to carry on with the same course, because we don't necessarily keep records of partially completed courses. You will always have record of a fully completed course. So I strongly recommend for you to get Math 3101A finished completely and knock that one out of the way before you spend too much time looking at 3101B. Okay? Anyway, thanks for being here with me today. I hope that was helpful for you. Yeah, as always, let me know if you have any other questions. Stay safe, and I hope to see you again tomorrow.